Hello, I'm Robert Ross, Department of Physics, Center for Single Molecule Biophysics and Center for Biological Physics here at Arizona State University. In my lab, we're using atomic force microscopy and optical techniques to study biomolecular structures and interactions at the single molecule level, cell adhesion at a single cell level, as well as cell and tissue mechanics. On this slide, you see a couple of examples of work done in my lab. On the left side here, we extracted chromatin from cells and we studied the nanoscale structures using AFM recognition imaging. We were in particular interested in how these nanoscale structures changing during cancer progression. On the single cell level, we are interested in the interactions of blood cells with biomaterials, especially with biomaterials which are used for vascular grafts. So the background is that the implantation of vascular grafts can trigger thrombotic responses. And we want to understand the mechanisms behind those thrombotic responses. We use a variety of technique for this project, including single-cell force spectroscopy, which allows us to quantify the adhesion of a single cell to biomaterials. On cell and tissue mechanics, we are working on three topics. First is we want to quantify mechanical properties of cells embedded in a 3D environment in tissue. For this, we are correlating confocal microscopy and atomic force indentation. This allows us to deconvolute the mechanics of a cell from the tissue environment. We were in particular interested how the mechanics of cells change when they invade into tissue. So if you have a metastatic cell and it invades in tissue, what happens with the mechanical properties of the cell? We are also interested in how the mechanics of the tissue change during cancer progression. For this, we are developing and utilizing 3D tumor models, and we are quantifying the mechanical properties of tissue. We are also interested in this to understand more about the remodeling on the molecular scale of tissue. And for this, my group was involved in the development of a new nonlinear microscopy technique, which is doubling the resolution and increasing the contrast by a factor of 4 compared to conventional nonlinear microscopy techniques. Nonlinear microscopy techniques are very useful for studying tissue because they are label free and you can image deep in tissue. If you are interested and if you would like to learn more, please email me here. Here's my email address. And I'm more than happy to set up a meeting and to discuss the work in my lab with you in detail. Thank you.